Welcome everybody. Good evening for those of you who are in Europe. Good morning for those of you who are in the United States. As usual, I will try to follow the chat if there is any question, but if I miss some, I will answer at the end. So it's today I am going to speak about visual astronomy and perception and the many blunders which can be made if you trust blindly what you see. I mean, I will show you in a few minutes, eyes, in spite of being very beautiful and being fundamental for our life, are also very deceiving machines, and therefore they also lead to many mistakes, and this has happened many times in the history of astronomy. So let's first of all start from what we call the acquisition channel. If you do any visual observation, either by naked eye or with a telescope, your observations, what you see, is going to be affected by two factors if you are observing visually, and three if you are using a telescope. First of all, the atmosphere. The atmosphere is not a neutral filter. Basically, it affects the signals coming from stars via several factors. One of them is transparency. We all know that we cannot observe at all wavelength. For instance, thanks God, the atmosphere shields us from the ultraviolet rays and from the X-rays. And therefore we have a first selection effect. The second one is transmission, because the atmosphere is not perfectly transparent to any visible wavelength. And furthermore, there is turbulence, and as we can see, this will play a relevant role in our story. Atmosphere is not a stable structure. Due to thermal variations and to density variation, it has a very chaotic and turbulent structure. So the light which travels across the atmosphere is subjected to many perturbation, and basically the light from a point source is shifted in a quite random way by the atmosphere. Then the light coming from the stars enter the telescope, and the telescope is not a perfect device. First of all, it has aberrations. We shall see in a few seconds what I mean with the term aberration, but basically it distorts both shape, colors, and luminosity. Then there is a problem with angular resolution. Every telescope has a limiting resolving power. In other words, cannot see as two distinct objects which are separated by distance smaller than what we call the resolving power. And finally, there is the enlargement, which also creates some problem. Then we are left with the eye. And since we are going to talk about visual observation, I think I will spend some time on the eye, which, as I said, very often eyes are incredibly beautiful. In Italy, we say that they are the mirror of the soul, but they are also very poor optical devices. And in fact, the first thing to be noticed is that the light which enters the eye goes through a single lens. And everyone who knows about optics knows that a single lens is the worst possible optical device. For several reasons. First of all, because a single lens cannot correct any sort of aberration. Therefore, we have an axial aberration, which causes that the light coming from even a small angle from the vertical axis, from the optical axis, is distorted. And the more distant, the larger is this angle between the visual axis and the optical axis. The larger is this angle, the larger is the distortion. And what is more important is also that light corresponding to different wavelengths gets focused in different parts of the focal plane. So at different distances from the focal plane. So in other words, if you can focus the red light, you are not focusing the blue light. If it were not for the brain and the retina who somehow take care of this effect, basically it would be impossible to see because each object observed, during the everyday life would appear, like aids of different colors. I mean, for instance, if you would focus your attention on the red light, you would see a red spot surrounded by blue halo just because the blue light will not be properly focused. This does not happen because the acquisition system of our eye is corrected by what happens both at the retinal level and what happens in the brain. But this is something which happens in a quite strange way and leaves a lot of mistakes. I will show you in a few seconds what I mean with mistakes. This is, for instance, the measurement. What you see on the left, on the upper panel, is how a point-like source is projected on the retina. And as you can see, an image which should be circular and very concentrated, it's actually quite distorted and very elongated on the retina. And the more you are far from the axis, the more distorted is this image, which basically transforms each point source into a sort of elongated and distorted ellipses. In this slide, I show you the main receptor. This is a quite important thing. I mean, also because many things which happen in our daily life depend on this strange structure of the eye. In the retina, which, by the way, is a mistake in some sense of the evolution, because at some point in our transformation from fishes into reptiles and then, monkeys and then human beings, somewhere during this process, the, the, the eye curved in the wrong direction, and therefore this is why the retina is mounted backside down, which means that the receptors are not in the on the retina, are not distributed on the surface of the retina which faces the light, but on the one which faces the back of our skull. And this was just an evolutionary mistake. But on this retina there are two main types of cells, the so-called rods and the cones. Let's first speak about the rods. Rods are basically only of one type, and they are sensible to very low light level. So basically, they are in charge of the nocturnal visions. Since they are only of one type, they do not allow us to see colors, and this is why during the night we see black and white. There is no way we can see color during the night or in any dark place. Cones instead of three types with three different spectrals and response. Basically, let me show you next slide, then we come back. The cones have a slightly different spectral response. There is a type of rods which are sensible mainly to the blue light, a type of rod which is sensible mainly to the green light, and another one which is sensible to the red light. And the feeling of color, because color is not an absolute quantity, it's just a sensation which our brain creates, comes out of a sort of weighted average of the signal coming from these three colors. By the way, if by any genetic defect one of these cones is missing, we have color blindness, and if one color is missing, you are mildly colorblind. If you have two types of cones missing or badly working, you have very bad color blindness. Basically, you are back to black and white vision. Why are no, sorry, this was the wrong one. Okay, let's go back to colors for a second. To rods. Rods are and cones are not distributed equally on the surface of the retina. Rods are mainly concentrated on the outskirts of the retina, so basically they are covering what we call the side view of the eye, while cones are mainly concentrated in the center of the retina, where we have the daily vision, and this is why this is also a result of evolution, of course, because it dates back to a very long time ago, when humans had to defend themselves against a predator, and at night they needed something very sensible and capable to detect very even the slightest movement, because the movement of something would have been a signal that the predator was approaching. And why do I say this? Because in the retina, rods are connected in a very strange way. It's basically neighboring rods which are one next to the other, turn themselves off if the signal does not change, and then suddenly turn themselves on if there is even the slightest variation of the signal. This acts as an amplifier of the movement. And by the way, as an astronomer, I want to specify that if many of you have been disappointed on the 10th of August because they have not succeeded in seeing the meteor showers, which are every year on the newspapers, we have a lot of publicity about this meteor shower which takes place on the 10th of August. Many people go outside, look at the sky, don't see much, and they're disappointed. This is because they look at the sky in the wrong way. Most meteors are not very bright, and therefore you need to see them with the rods, which means that you need to use only the side view of the eye. So if next time you want to see a meteor shower, go outside in a dark place, look to a not very bright star constantly. Do not move your eye from that star. And in that way, you will be very sensible to what takes place on the sides of your field of view, and you will see many more meteors than if you would have done differently just by looking for them. With this trick, you activate night vision and you take advantage of the exclusive properties of the rods. So, let's go to next slide, which is also a very important thing. Let me make an analogy with the computer. Everyone who has a computer knows that you need to have a video card. Very few people ask themselves why they don't need also a specific electronic card for the keyboard or for the mouse. And the reason is just the data transfer. A keyboard and the mouse basically transfer to the motherboard of the computer only a very limited amount of bits per second, because we cannot type that fast, and also, we cannot click the mouse more frequently than a very small amount. Video, the monitors are completely different thing, because a monitor, even the simplest monitor, is made by almost 1400 by 800 pixels, so about 1 megapixel, 1 million pixels. These pixels need to be refreshed 30 times per second in order to give you, a nice feeling when you are watching a movie. And then each pixel is represented by 24 bits, which means that if you multiply all this number, in order to visualize 1 second or image on your monitor, you need to transfer from the motherboard to the monitor 720 megabytes, which is incredible. For two reasons. First of all, because it's a very large data transfer, but also because every time you transfer a bit of information, you need to dissipate some heat. Now, if we do the same thing for the human brain, things get much more complex because you have 120 million rods plus about 10 million cones, which means that in your eyes you have 130 megapixels, 10 frames per second because this is the acquisition time of your eye, and basically you have an 8-bit word per each receptor, which means that your eye should transfer 10 gigabytes per second to your brain. This is not physically possible because if the retina was transferring this amount of information to your brain, the heat to be dissipated would be so large that your brain would boil in your skull in less than 1 minute. Thanks God, nature has found a nice trick to prevent this, and yeah, my brain boils a lot too, but for different reasons. We are both human beings. Life can be difficult sometimes. But no, in this case, it would truly boil. I mean, it would get roasted by the transfer of information. So what happens is that from the retina to the brain does not go the complete amount of information, but just a very small fraction. The retina is structured like a complex neural network, which does a huge pre-analysis, a huge pre-selection of the information which you need, which then is sent to the brain. For each 1,000 photons which fall on the retina, only one generates an information which is transmitted to the brain. The retina is responsible for an incredible amount of things which we give for granted. For instance, the retina is the one which understands whether a structure we are observing is vertical or horizontal. The retina understands whether two adjacent, whether two objects are connected to each other and so on. And a proof of this is in the so-called optical illusion. I mean, here you have if you are well aligned with the screen, you have very familiar examples of optical illusion. The two squares surrounded by circles are perfect squares, but the sides appear bent to us just because the information, because of the way the retina transmits the information to the brain. And also the two parallel lines on the left image do not appear parallel to us just because of the way the retina is scanning the image and is selecting which information to send to the brain. Now, this very often optical illusion are regarded as almost as a sort of a game, but they're much more than that. They tell us a lot about what is going on in our brain. For instance, look at this. I mean, here we have 3 examples of the same things. On the left, let's start from the upper one. You have 2 segments which are marked by the tip of the arrows. And the segment on the right, it seems much shorter than the one on the left, while they are absolutely equal. And the same thing is true for the 2 red circles in the middle of the 2 flowers, in the second image. Basically, they are identical, but they look of different sides to us, just because they are surrounded by objects of different sides. And even more impressive is the last image, where you have the feeling that the card on the left is smaller than the card over the right, while they're exactly the same card, just pictured twice. And this is a phenomenon which is due to the way an image is analyzed by the retina. So basically, the retina finds the edges, then measures the position of the edges, and transmits this information, edge and position of the edge, to the brain. So basically, while reading, for instance, the image with the two cards, she starts on the upper left yellow corner of the card, and then goes down. When the retina moves to the next card, she has to go up. So the signal which is basically sent to the brain is that she is extending her view, and therefore the second card looks bigger than the one on the left. Why this is so important? Because most of our perception is affected by this. We just are not conscious of it. Look at this image. This is quite famous. You see two green and white squares, and then you see two distribution of one, let's say, pink squares, and the other one which seems red, darker. Well, I mean, I know it's hard to believe. You can stare to this image for half an hour, and you will never realize that actually all the red squares are exactly the same color. Those which appear darker are exactly of the same color of those which appear lighter. And the fact that you perceive them as darker is because in one case the squares are surrounded by white squares, in the other case they are surrounded by green squares. And therefore there is a sort of alteration of the perceived color by the brain. If you don't believe this, you can just go on the internet, download the image, and then use something to look only to the color. Just put a piece of paper on the screen so that you can only look at the red square, and you will be impressed because they are exactly identical. The first time I did it, I learned a lot of things from this experience. Let's see. Look at this image. What is carved in the center? I wait for 5 seconds, please. If someone who has never seen this image before can tell me what is carved in the center, write it in the chat. Basically, it seems like a random carving, you know? Well, you will be impressed to see that just by turning this thing by 180 degrees, you will immediately realize that it is a deer. It's exactly the same, just was upside down. So basically, the pattern which was observed by the retina and was transmitted to the brain was not matched by any previous image in the database which we have in our memory, and therefore it was not recognized by the brain. Holy cow, I agree with you. It's the exact reaction. So, you know, when people say, I have seen it, and you say, no, it's not possible, well, be careful, because very often two people sitting in the same room, one next to the other, can perceive completely different things, can perceive in two completely different ways the same phenomenon. And this is also why in trials, one eyewitness is usually not enough. You need at least two or better three, because you need to reach a consensus of what is what was a real perception of the things. Okay, let me go now to the final thing. Look at this image. On the left side, you see three pillars. On the right side, you see two. On the left side, the three columns. On the right side, two pillars. Then, if you compose the image, you get this, which is an impossible image, but your brain understands that there is something wrong, but is not capable to identify the place where this wrong happens. And this is because the retina scans the image in a sort of raster-like way, basically by horizontal lines. And so you perceive the signal in a rasterized way, while the interpretation of the signal is global. And there is a conflict between the differential perception operated by the retina and the global perception, which is an interpretation operated by the brain. Now, there are hundreds of books on the paradox of vision because we have, thanks to modern science, we have understood a lot of how the process takes place. And this is due to this understanding that, for instance, now we have the first robotic vision, we have the machines which imitate our vision, but there is still a lot to be understood, and especially for what it concerns the way these images are understood by our brain. But the most incredible thing is that outside of all this chaos, we have a sort of stable, remarkably stable perception of the world. Okay, so what is the astronomy? Because don't forget that I am an astrophysicist, so now I need to go back to astronomy. That before we could have instrumental measurement, astronomy was done by naked eye. And these observations made by naked eye are, like all our vision, affected by what I have discussed till now. Basically, our eye is a terrible optical instrument. The process of vision is very complex. We have a loss of information in the process which transfers the information from the retina to the brain. And finally, we have the problem that our brain needs to understand and what he is seeing by putting it into categories which he has somehow built in its own database. And therefore, it's not a surprise that the history of the early astronomy is full of interesting facts related to vision. First of all, if you look at this, is just an interesting piece of information. If you look to the first stellar catalog, the one by Parcus, which was then published by Ptolemy in his Almagesto, you find that Sirius, which is the brightest star in the night sky, which is a wonderful blue-white giant, is described by Ptolemy as being red. This has never been understood. It has been confirmed by several translations by several ancient authors. It seems like during the Greek time, Sirius was perceived like a red star. There is no way to understand whether this has to do with the different perception of the colors, or rather with a different properties. So one astronomical explanation of the phenomenon could have been, a cloud of dust interposed, interstellar dust interposed between us and the star, which could have reddened its light. But we don't, with modern instruments, we don't find any trace of this cloud. So, I mean, the question is still open, and there are many things to be said about this. It is very likely that it is just an artifact of the fact that the Greek had a completely different perception of the colors. I don't know how many of you have watched the movie by Walt Disney, which in Italy is called Fantasia. Fantasy, I think it's a movie where there are animation, playing on beautiful pieces of classical music. The in Fantasia, there is one episode which is staged in the classical Greece, and if you see, the colors are completely wrong. The the sky is dark, the the trees are reddish, the leaves are not green but they're red, and the water is blue, and the air of the small mythological creatures are azure. This was not done by chance or because the people who made the cartoon, the animation, were under drugs. Actually, they were quite knowledgeable people. Because if you look to the old Iliads, you discover that the colors which are described by Homer, are completely different from what we see nowadays. The color of the hair of Achilles is blue. The sea is depicted as the color of the wine. And there is, in fact, a long-lasting discussion in the anthropological and the classical community on the different chromatic scale of the Greek, just because the color is a convention, is a software which is in our brain, has no physical nature, the color. Wavelength, frequency, is is a measurable physical quantities, but color is a perception. So if you program the people with a different software, you get completely different answer. It is very likely that the Greeks had a completely different perception of the color with respect to what we have nowadays. So let's move on. And let's go, for instance, to the face on the moon. This is a typical retinal pattern recognition. Human being, the brain is not capable to perceive an intricate structure. That would require too much stress on the brain. So the retina, especially when the structures are at the limit of the angular resolution of the eye, the retina performs a strange operation, connects the points together. And this is why when you look at the moon, when you were a kid, and your mother saying, you look to the man on the moon, or to the rabbit on the moon, the old man on the moon, the hunter on the moon, even Wilma on the moon. What you see on the moon is due to the fact that the retina is not capable to distinguish the details, and therefore connects the point together and tries to group them into familiar shape. Which is the shape depends on your culture. So, for people in the West, basically it was the man on the moon. But for instance, for the Native Americans, it was the hunter on the moon, the one you see on the right, or was it the rabbit on the moon? And this is quite interesting, because from this also a lot of legends and a lot of myths originated. So, for instance, in Europe we have many legends on the man on the moon, which are just due to the way our retina works. This is sort of an issue. Similar things happen nowadays also. It is very famous that in 1976, when the Viking orbiter took a picture of Mars, many people claimed to see the face of a monkey on Martian surface. And as you can imagine, many people who are believers in extraterrestrials claimed that it was a monument left by the Martians, or by other aliens, as a sort of sign of their presence on our planet and so on. There was no way to try to convince these people that they were just, a strange configuration of shadows which were interpreted as a face by the human brain. And even in 1998, when a second orbiter took a different picture under different lighting of the same structure, which is the one you see on the right of the image, there was no way to convince that there was no phase. In fact, these people claimed that NASA had falsified the second series of picture because they didn't want to give the proof of the existence of extraterrestrial life on Mars. And then after a while, other people, connected in a different way the signs on the second image of the face, and they found again the evidence for a face. So this is why I call it a resurrection of the face. It's every time you have any structure, the pattern, the brain tries to reconstruct familiar patterns, as you have seen before with the deer. And since one of the things that our brain is very good at doing, actually one of the things it does it best, is to recognize faces. It's very easy for the brain to spot faces even when there is no one. For instance, look at this structure on Mars. You like it, it looks just like a strange structure. Then you look to the other side of the thing, and you don't see much. You put two things together, and you have a fantastic image, of a bald man with a huge ear and nose and eye and so on. It's just a normal geological structure, on the surface of Mars. And then it's full of this. This is Terminator on the moon, the rock on the right. And this is a praying man on Mars, which was observed by the rover, which according to the political and cultural scenario has been called the praying man, by religious people, then the terrorist on Mars, the Yeti on Mars, and this type of thing. It's just a rock. And our brain, in looking at the image, forces it into the database cell, which tells you, it's a human figure. Yeah, that's my uncle, I read it. And, okay, the same happens when you observe through the telescope. And here we have a very nice fact. For instance, one of the first people to observe the sky was this almost unknown, he was a sort of a genius, almost unknown Neapolitan astronomer, Francesco Fontana, who was immediately after Galileo, was observing the sky, and he observed, obviously, one thing which needs to be understood is that at that time telescopes were something completely different from what they are nowadays. They were small, they were only one lens, therefore they were affected by all types of aberration. The glass from which the lenses were made was green and full of bubbles. So basically, to see something through those telescopes was more a miracle than a scientific fact. But some people succeeded in doing it. And Fontana had a very aberrated telescope, so he made the first drawings, of the surface of Mars and of Venus. And on Mars, he saw a central spot surrounded by an halo, but we know that very well that this is a sign of poor optics nowadays. We know very well that it is a sign of spherical aberration on this telescope. And in other words, it was just a mistake caused by the integration of a poor telescope with a poor eye. The more interesting is this history also because it's a very nice story. At the very early stage of scientific development, when people wanted to communicate a discovery, they didn't have what we have nowadays. They didn't have specialized journals. They didn't have, press releases, and so they basically used either mail. they sent letters to other scientists distributed in Europe describing their discoveries, or in some cases they wrote books where they made a complete and detailed description of their findings. Sometimes it happened that they made a discovery. They had the feeling that discovery could be interesting, but they didn't know how to communicate that because they were afraid that someone else could have stolen their discovery. And so they used anagrams. And Galileo was a professional in doing this. When he observed the phases of Venus, he sent an anagram to Giuliano de' Medici, which translated would have been the mother of love, quindi Venus. Venus was the love goddess for the Greeks, imitates the behavior of Cinzia. Cinzia was the moon. Therefore, he was saying that Venus had the phases exactly like the moon. So basically, there was a full Venus, the first quarter and the third quarter of Venus, which was quite important discovery because it was the confirmation of the Copernican system. Therefore, it was important discovery. The nice thing is that Kepler, who was a fond admirator of Galileo, but Galileo was a bastard. From the human point of view, he was such a great scientist, like he was a terrible human being. And he always felt that this Kepler basically was not at his height, and therefore never took. While Kepler was adoring Galileo basically paid not any type of respect to Kepler. But Kepler tried to decipher the anagram and came out with a solution which was completely different. Macula rufa in Liove est giratus matem, which translated is there is a red spot on Jupiter which rotates mathematically, which is surprising because by making the wrong translation, he predicted involuntarily the existence of the red spot on Jupiter. And this was a singular coincidence because the red spot on Jupiter would have been observed 60 years after this Kepler solution. But the nicest thing is that happened when Galileo observed Saturn. When he observed Saturn through his poor telescope, he immediately realized that there was something which didn't work. But he really could not understand. He repeated the observation many times and could not understand what he was seeing. So he sent this sequence of letters as an anagram to his correspondent in the Collegio Romano of the Jesuits, and circulated this same sequence of letters all over Europe, so that he was basically putting his hat on the discovery. And Kepler again made the wrong translation, which you can see below, and Saliu umbistineum geminatum Martia proles, which means hail, twin companionship, children of Mars. Again, by making the wrong translation of the anagram, Kepler imagined the existence of two satellites of Mars, two satellites which would have been discovered only 300 years later in 1801 by Asa Fool. So basically, it's a singular coincidence which happened twice. Kepler had a very bad luck. Basically, he was trying to understand what Galileo was writing, and both times came down with the two translations which were true and would have been proved true only many years after his death. Well, history of science is full of these strange facts. But what Galileo was writing was something completely different. He was writing altissimum. If you put the letters in the right order, you get altissimum planetam tergeminum observavi, which means I have observed the highest planet, the more distant. At that time, the most distant was Saturn, to have a triple form. His optical system was so bad that it obviously could not recognize the shape of the rings, but also he just could see that there were two spots on the sides of the planet. So he thought that Saturn was actually formed by three stars. And this discovery that this sort of triple nature of Saturn circulated quickly across Europe, using this letter system which I told you. And to tell you, one of the things I've done in my life, one of the strange things I've done in my life, and this also when I became a good friend of the director of the Prado Museum in Madrid, is when going there, let me go first here and then come back. I realized that there is in the Prado there is this painting by Paul Rubens where he is depicting the god Saturn devouring its children, and above the uh, the god there is a triple star. This was done. This painting was made in 1636. Galileo had written his letter in 1610, and the true nature of this triple system of Saturn would have been discovered only by Huygens only in 1651. So, and no one had ever paid attention to the three stars, just because, expert or modern art very seldom know about astronomy. So, the director of Prado was very impressed in reading the writings by Galileo about the triple nature of the Saturn. This is a fantastic example of how connected were all intellectuals in Europe, across Europe, in the already in the 15th and 16th century, and 17th century. A painter in Madrid was well aware of the latest scientific discovery made by Galileo in Europe. And this is something which should be kept in mind. At that time, there was a sort of unity of knowledge which is almost completely lost nowadays. I will bet that most painters would have no idea what quantum mechanics is or what modern cosmology is. And this is a pity. It's something we should really try to correct. Let's go back to Saturn. As you can see here, you have the evolution of the drawings of Saturn, and you see that very complex shapes were invented. You have amphora-like shapes, you have a sphere like two handles, like for instance in the seventh drawing. And so these are all from different astronomers who, due to the bad performance of their telescopes, were not capable to realize what was instead understood by the he brought DNA, he brought a fourth dimension, he even made the crucifixion using a tesseract in place of the cross. I mean, Dali was an exception in this respect. I agree. Sorry. Now and again I read the chart and I comment on what I see. Christian Huygens also communicated the discovery of the ring around Saturn through an anagram, which translated means basically the ring is around the planet. It is a very thin ring, a planar ring, and very coherent and inclined with respect to the plane of the eclipse. Okay, and now let's go to what is the typical. Sorry, I'm fighting with the mouse. Mars. Every one of you must have heard about the channels of Mars. And here also there are very funny stories. The channels of Mars originated from this man, Giovanni Schiaparelli. Giovanni Schiaparelli was an outstanding brain, an outstanding scientist, one of the best scientists of his generation. He was an Italian, he was director for many years of the Observatory in Milan. He was an incredibly knowledgeable man, and he was a he studied under Encke and under Otto Struve, who were the leading astronomer of his time, and he's the man who discovered the connection between fossil comets and meteor showers. He was one of the leading experts on double stars, but more than that, he was he spoke more than 20 languages. That's in live Sanskrit, Latin, Greek, whatever you can think. And he was also, a very good historian of science. So basically, he was a sort of a Renaissance man. And he was using the instrument of the observatory in Milan, which were modern achromatic refractors. Actually, he was using what at that time was the largest refractor in Europe to observe the surface of the planets. Uh, he already on Mercury found the strange patterns which you can see in this map, but where he really made his discovery, which now we could say is his blunder, is on Mars. Mars is very difficult to observe with the telescope because it's a small planet on which, with the distance which varies a lot during the Martian year, during its movement around the Sun, the relative distance between Earth and Mars can change by factor 3. And astronomers basically used the oppositions to so the moment when Mars was closer to the Earth to make the most detailed observation. If you look there on the right, you see that the red circle is the orbit of Mars, the blue circle is the orbit of the Earth, and as you can see, you have an opposition when the Earth and Mars are on the same side of the orbit with respect to the Sun, and since the orbits are ecliptic, the distance between the two planets, also at the opposition, can vary a lot. But one of the most favorable opposition was in 1877 when Galileo was observing the sky, and when Schiaparelli was observing the planet. And before telling you about the planets, I must tell you that the idea that this structure on the surface of the planet, which we call as the canals on Earth, is a result of a wrong translation from the Italian. Schiaparelli never said that this structure were artificial. He used the word channel. In English, there are two different versions of the word: canals, which means artificial, and channel, which means natural. In Italian, we have only canali, which can mean both, and you must understand what is what from the context. When people translated into English the word canali, they used the term canals. And this suddenly prompted in the imagination of the people the idea that this structure could be artificial. And this was the beginning of the end. Don't laugh at this because this mistake is done very frequently. For instance, one thing which I always find very funny is why a car is called a spider. I mean, this is a fast car. What has it got to do with an arachnoid? Nothing. It's a mistake of translation. It was invented in Italy. Italians sold it to the market saying speeder, faster. But when they were selling it to foreign buyers, they wrote it down as spider, because in Italian speeder is written spider. And therefore nowadays we keep calling arachnoid fast cars. Well, that's just an example of how mistakes can propagate and can become part of normal culture. Okay, what did Schiaparelli see? Schiaparelli saw this on the surface of Mars. So, originally, as you can see, this drawing depicts long black lines, contorted black lines, varying shapes, basically what could be channels, basically, rivers, river beds, things. So basically, natural structure. Then, in the following years, by repeating the observation, the structure became more intricate. This is a subsequent observation of Mars by Schiaparelli, where you can see that the channels have become mainly canals. You have some channels, so basically curved structure, connected by straight lines. And this error was basically believed for two other reasons. First of all, because he had the best instrument in Europe and also in the United States at that time. And therefore, scientists believe in their instrument, and therefore, they thought that what Schiaparelli was drawing was real. And since, he was depicting this structure, even observing seasonal variation, where some channels were splitting and this becoming darker and this type of things, they believed that this had to be true. And so all the other observers who were operating with lesser telescopes claimed that they could see them too. And therefore it became this obsession for the canals. In this moment, Percival Lowell in the United States becomes infatuated with the idea of Schiaparelli. Basically, he wanted to demonstrate that there was life from Mars. And Lowell was not a student at all. I mean, he was from a wealthy Boston family, and his brother was even the president of the Harvard University, and he graduated from Harvard with distinction in mathematics. And he has also been a foreign secretary and counselor for the special diplomatic mission of the United States. So he was a quite brilliant, knowledgeable, and well-read person. He became an expert of Japanese culture, and but at some point he read the books by Schiaparelli, fell in love with the problem of Mars, and he used his fortune, family fortune, and also some wealthy donor to build what is nowadays a Flagstaff Observatory in the United States, also known as the Lowell Observatory, where he put the largest refractor ever built, so the best telescope ever built. And he waited for the next observation, the next opposition of Mars, to see whether he could improve upon the, the work by Schiaparelli. He also read the book by Camille Flammarion, who was one of the best popularizers, astronomical popularizers in the world at that time. And he came out with the most detailed maps ever of the surface of Mars. Mars was completely covered by channels. These channels, in some cases, had also parallel channels, and this was due because during the peak of the stormy season, the amount of water to be transferred from the poles to the equator would have doubled. This is why there were double channels. There was a sort of sociological description of the. Yeah, it is a centipede. I have to recycle this. And it's the which became immensely popular, and we have echoes of these beliefs even nowadays. If you ever seen the movie John Carter over Mars, which came out 5 or 6 years ago, the geography of Mars, which is of that book with Barsoom, this is the name of Mars for the local natives, according to Edgar Rice Burroughs, who wrote the book. The topography of Mars was derived from Lowell maps. So it's, even in recent movies, people exploit the observation of it. But then, the problem is the following. You send the space probe, and on the right side, you have the real image. What really is on the surface of Mars. And as you can see, there is no trace of the canals. There is no trace of the channels, whatever they are. There is a strong agreement in the position of the large dark spots, but simply the channels do not exist. Where do they came from? The story began already in the beginning of the last century, around 1920, when the new instruments and a new generation of more skeptical astronomers who had a better understanding of the vision process began to inquire and to question the statements by Schiaparelli first and Lowell immediately after. And one of these observers was Eugene Antoniadi, one of a Greek astronomer who lived and worked in France, who was basically became one of the world experts of Mars. And using the new observatory in Medan, who had an 83 centimeter large refractor, which was huge for the standard of the time, he could never see a channel. He could never see the structure which had been observed by Schiaparelli or by Longo. And now the problem was where these channels came from. Here you can compare above the map by Schiaparelli and below the map made by Antoniadi. And as you can see, now you can begin to have a perception of where the mistake by Schiaparelli originated. In place of this network of very elongated canals, you find a lot of dark spots. Dark spots which are structured on the Martian surface, which due to the poor resolution of the telescope were too close to be resolved separately. And the eye played the same trick you have seen before in the optical illusion, connected the points to form straight segments. So therefore, the channels on Mars were the results of an optical illusion. But was an optical illusion which was shared and reproduced by many observers who were using similar instruments. What I said before, what is incredible is that this illusion, the way our brain simplified information coming from the eye, is remarkably stable. And therefore, while this is a statement by Antoniadi, but I think that more than many words, one image can explain it better. Antoniadi showed that the same region above as observed by Lowell and the same region as was observed by him. And here you can clearly see how the network of dots which you see in the lower picture was transformed by Lowell in a channel, in a canal. So, if there is a conclusion to this talk, is that you should never trust your own eyes. Never. Thank you very much. If there is any question, I'll be more than glad to answer. Thank you very much. Thanks a lot. Okay, I'm a shy guy. Stop the compliments. And if you have any question, tell me. Thank you. To tell you the truth, I think that sooner or later I'll end up writing a book about strange facts in astronomy because it's astronomy is full of these things. Oh, what I think of the new image of Pluto from New Horizons, that they are fantastic. They are really incredible. It's something I would have never dreamed to see. An image of the surface of Pluto with that metallic hydrogen flowing on the surface. It's really The universe is a place which is incredibly more fascinating than we even the wildest science fiction can imagine. It's really incredible. But I will try when I retire. It's a promise. Any question? I'm going back. Oh yes, Patio. There was an observation of a green wave that came every spring on Mars. Yes, it was already detected by Schiaparelli, but Lowell really insisted on that. Uh, since the opposition usually took place also at the time when Mars was closest to the Sun, there was a change in the coloration of the structure, which became darker, and also a change in color on the surface, which seemed to become darker, that were explained by Lowell as, a green wave, basically as a vegetation growing to the uh, larger amount of water available. And actually, basically, he was the only one to observe it. I mean, other people tried to observe it, but no one ever succeeded. I think that Lowell was really a victim of his own imagination of. And it also it can also be a result of the fact that, uh, different reflecting condition due to the fact that the planet was closer to the sun. There is no real good explanation for that. Yeah, I don't see any other question. Oh, no, 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 no. First of all, because these channels were, I mean, there are many things in this question. First of all, they've found the signals of water on Mars since 1896. This is a different and long story, and also very funny story. I mean, NASA and the European Space Agency every 6 months claim they are discovering water on Mars, but this is just public relation in order to convince politicians uh, to fund the space mission, expensive space mission. But the water on Mars was discovered in 1906 by Vaux, who was an astronomer who detected water vapor lines in the Martian atmosphere. Uh, so let's say it's not a discovery, it's a rediscovery of the water on Mars. And these channels were a huge structure. I mean, if you convert the drawings by Schiaparelli, these channels should have been 200 kilometers wide and several thousand kilometers long. And well, there is no way you can erase such a structure in less than 100 years. Also, because after the huge upheaval which took place on Mars about 3 billion years ago, I mean, the atmosphere on Mars is quite stable. I mean, there is no real sign of any climate evolution. It's a quite desertic place, cold with a very shallow, very thin atmosphere with huge amounts of water, but this water, is frozen into the first layers of the surface in the permafrost. No, so therefore no. these channels, these canals have never been there. I mean, they were just an optical illusion. Mhm. Oh, nice to know, Patio. I will attend it. Same time, same place? Okay, I'll be here. I'll be there. So now, if there are no other questions, I go to my dinner. Okay. Thank you very much, and also you enjoy whatever it is, either evening, morning, or whatever. Okay. Have a good day. Bye. Thank you.